Hi everyone, this is going to the part 2 of the chapter named triangle, in which I am going to discuss the concept of the BPT along with the exercise of the NCRT, and in this I am going to discuss the question number 2 and 3. So if you are thinking that why you are not discussing the question number 1 of the NCRT of the 6.2, so this is because the question number 1 is very easy, that I would not like to waste your time in discussing such question, and already I have discussed the 6.1 NCRT along with concept. So today first I am going to teach the concept, which is the BPT, which is also called the Thales theorem, or the BPT stand for the basic proportionality theorem. And then after I will discuss this question, which you will feel to very easy to solve because the concept is going to be the rigid. So what is the meaning of BPT and how we implement and use the BPT, and what is the BPT? So for this you have to understand about a triangle. Let's suppose we have a triangle here. We have a triangle here. This one triangle name as the A, B and the C. So as we have the triangle ABC, now let's suppose draw a line name as the D and E. So when we draw a line, let's suppose this DE which you draw a line, let's suppose this is only the parallel to the BC. When the DE is parallel to BC, then we get a new thing which you have to understood, that is called the BPT, that when you draw any line which is parallel to the line sides of the triangle, then it divides this one by this one is equivalent to this one by this one. So this can be written as the AD divided by DB is equivalent to AE divided by EC. So what is the meaning of this one? So only this is the valid only when the one line is parallel to the one side of the triangle, then this is going to happen. So what is the meaning of this and how will you use this in the triangle? Let's suppose this side is the 4 centimeter and this side is the let's suppose this side is the 2 centimeter and this side is the 4 centimeter and this side is the 6 centimeter. And if I will ask you what is going to be the length of this one when the DE is parallel to EC, that you have to understood that only this the concept of BPT which you can use only when the one line is parallel to the other side of the triangle. So as we have this condition, so through as we know that DE is parallel to BC, then we could write this thing, that is the AD is equal to DB and which is AE, and AE is equal to EC. You could write this one. Now you know the value of AD which is the 2 and the DB which is the 4, and AE which you have to find, you don't know the value of this one, and the EC which is the 6. So when you cross multiply, you will get that 12 is equal to 4 AE, and then it will cancel out in 3 times. So the AE is going to be the 3. So through this theorem you will able to find that this side AE is going to 3 centimeter. So what is the meaning of this one? As you get the AD is equal to DB. So now you have to understand that using this you could write here the 2 by 4, because the AD is 2 and DB is the 4, and which is equal to the 3 by 6, and it doesn't seems to be the equal, as we know that this is going to equal using the BPT theorem, but it doesn't seems equal. So when you will simplify this one, you will get 1 by 2, and when you simplify this side, you will get 1 by 2. Now you know that 1 by 2 is equal to the 1 by 2. This is why you get to know how we have to use the BPT and what is the meaning of BPT in a triangle. So I think you get to understand now this thing which you have to keep in your mind, and using this thing I am going to teach you some other concept which you could use. So for this I have to erase this one. I am now making a new triangle. Let's suppose we have the another new triangle, which name is the ABC, and let's suppose we have a line which is the DE. So you could write the AD is equal to DB, which is equivalent to AE is equal to EC. You will say this can be written, but this is the wrong. But wow, because I doesn't mention anywhere that DE is parallel to BC. So this is only valid when the DE is parallel to BC. So if we consider that DE is parallel to BC, then this is going to be the right, and this is the one form which you will use. And the another form, this same thing can be written in the another form, just changing the the face of this one. So this can be also written as we have written the ratio of this one dividing by this one, or dividing this one by this one. Now you could write here dividing this one by this one, which that means the AD divided by whole this AB, and this can be written as the AE, which is the AE can be divided by whole AC. So this can be written like this one, and you could also write this one like dividing this one by whole this, that means dividing the DB by the AB, and then dividing the EC by whole this AC. So this is the alternate form of this one, but main thing which you have to remember, that is this one, because these are the form of this one, just we change the face of this, then we will get this ratio. This is like the corollary, that main thing is this which you have to remember. Now using this concept we have to solve the exercise of the NCERT, and I think you will able to solve because I teach you a concept very well. So now solving the NCERT question. Now we have that E and F are the points on the side of the PQ and the PR of a triangle PQR. For this now you have to make a triangle PQR. So we have given that we have a triangle name as the PQR. Let's suppose this one is the P and this one is the Q and this one is the R. Now reading question once again, we have the E and F are the point on the side PQ. So we have side PQ where E is the one point, and then we have the F are the point on the PR. So we have this side is the PR and we have here the point F. So as we get the 2 point in triangle PQR, which we have the triangle, for each of the following cases state whether the EF this one is parallel to this one or not. So we have to identify either it is parallel or not. We have the three cases, first cases, second cases and third cases. We have get with the values, and for which we have to identify either the EF is the parallel to the QR or not parallel to the QR. So in the first cases I am going to discuss the first case, in which PE, which is equal to the 3.9 centimeter, and the EQ which is the 3 centimeter, and the PF which is the 3.6 centimeter, and then we have the FR which is the 2.4 centimeter. Now we have to state whether the EF is parallel to QR based on the value we have given with. So if you have to check either it is going to be the parallel or not, so you have to use the concept of BPT. Let's suppose for this we have to consider that, let's suppose the EF is parallel to QR. EF is parallel to QR. When we let's suppose the EF is parallel to QR, if these lines are parallel to this one, as we suppose, then it will follow the concept of BPT, that is the PE, that is P divided by EQ is equivalent to PF divided by FR. If it will follows the concept of BPT, then it is a parallel. If they were not able to follow, then it is not parallel. So as we know that PE is equal to 3.9 centimeter and the EQ is the 3 centimeter now, and PE is the 3.6 centimeter, and this one is the 2.4 centimeter. Now we have to check either it is the parallel or not. So as you know that decimal can be removed as we have the both side. Now this decimal can be here, get the 10 here, and as we have with this one. Now we have here which can be written as 39 by 30 and which is equal to 36 by 24. Now this can be cancelled out in the 3 time. That means this can be written as the 8 and this can be written as the 1 2, because we cancel out in the 3 time, and here the 13 by 10. Now we will solve for now as we get here, this is the one that 13 by 10 and we have this one which is the 12 by 8 which is not equivalent. So as it is the not equivalent, so what we suppose is the wrong. Whatever we suppose is the wrong, because we suppose that EF is parallel to QR, then this must be equal, but here we not get the equal values, then this we condition we suppose is going to wrong. So we have to find a state whether the EF is parallel or EF is parallel to QR. So in the first case it is not parallel because the rule is not being followed. Now we have to check the second case. Now solving the second case, and we have to state again that whether these lines are parallel or not. So in the second case we get the PE which is equal to 4 centimeter and the QE which is equal to 4.5 centimeter, and here we get the 8 centimeter and here we get the 9 centimeter. Then again we have to let the EF is parallel to QR. If it is parallel, then it will follow the concept of BPT, which means the PE is equal to EQ, which is equivalent to PF is equivalent to FR, and here the PE which is the 4 and EQ which is the 4.5, and again we have here the 8 and 9. Now if you are going to solve this one, again you will able to see that this is not going to be the equivalent, because when you remove this one you will get here the 40, that means 40 by 45, and here we have the 8 by 9. But when you cancel out in the 8 time and here it will in the 9 time, so as we able to see that 8 by 9 or 8 by 9 which is the equal in the both of the cases. So whatever we let that the EF is parallel to QR. So whatever we let is the correct. So and the ratio is the equal, then we will say that in the second case, using the second case we could say that EF is parallel to the QR, because in the first case this is not going to happen, but in the second case we get. So the second case is the right, yes, the EF is parallel to QR. Now solving the third case and reaching to the answer. Now what we have in the third case. So these are questions for the practice, for which you could make your concept to be very rigid of the BPT, and through this you could understand how we have to use the BPT. So in the third case we have which is the 1.28 here, the PQ, sorry, now we have the PQ which is the 1.28 PQ. As you know that if it is the parallel, let's suppose the EF is parallel to QR, then you could write here the PE PE is equal to EQ, and which is equal to PF is equal to FR. So like this you could write, but now here we are getting the PQ and then PR, such a values like the PF and the P. Here we get the PQ and again the PR. Here we get the PR and then such values. So how will you solve in such cases that if you are getting the values like the PQ, as we haven't here any type of PQ, and here we have the PR that means this value we have, and the PE that means this value we have, and the PF which we have. So this is going to be the critical thing which you have to solve. But this is the, as I teach you, the three type of identities based on this. This can be written, I think I had made a mistake in writing somewhere. This is the PQ and this is the PR. We have the PQ and the PR, just right here. So as I teach you, this can be written in the three form, that is the PE is equivalent to PQ, and again the PF is equivalent to PR. As I teach you, we have the other two form, like this one form and the another form which we have, that EQ is equal to PQ and again FR is equal to PR. The three cases already I have teach you when I am teaching the concept of BPT. So now we have to see that this So using this first case, we will not able to solve this question because the values are given like the PQ and so on. So which case we have to use? Now if you will see that which one case we have to use, then you will able to see that PQ we have and PQ we have in both of the cases. Now we have the PR and PR we have in both of the cases. Now PE, where we have the PE have only in these cases. That means this case you have not to use in this question, you could use in the other question. Now the second case we have to use in this question to prove. So right here the second case, which is the PE is equal to PQ or PF is equal to PR. So we have the value of PE which is 0.18, this can be written as 0.18, and we have the PQ which is the 1.28, and again we have the values of the PF and which is the 0.36, and we have the PR which is the 2.56. And I think you know how to solving such values, and it will all be cancel out because we have both side in the numerator and denominator the sign of like this. So I think you get to know that at this point. Now you have to solve either these values are equivalent or not. So if you will solve, this will be cancel out in 2 time and this will be cancel out in 2 time. So here we get 1 by 1 which is equal to 2 by 2, and when you will cancel out you will get this side is also 1 by 1. So in this case you get that both of the side are equivalent. So you could also say that in the third cases the lines are parallel, because we have to state whether the EF is parallel to QR. So only in the first cases the EF is not parallel to QR, but in the second cases and the third cases we have the parallel. Now solving the third question, which is a very interesting over this concept. So now how will you solve? For that third question we have given with a figure which is this one. Now in this we have to prove AM. Now we have given that in the above figure the LM is parallel to CV. What is the LM here? So we have the LM, this one line is parallel to CV. Now here we have the CV, this one. So we have get that the LM is parallel to CV. Now we have to LM is parallel to CV, and the another thing we get that LN, this one is parallel to CD. This one is parallel to this one. Now we have to prove that AM is AM by AB, which is equal to AN by AD. Now how will you use the concept of BP to prove this one? So for this you have to consider that what is the question required and how we'll proceed to this. So for this you have to see whether we have the AM. So as you are able to see that AM is this one line, and AB which is the this one line, and AN we have this one line, and AN we have the and another AD we have the this one line. So for this you have to see the two triangles you are getting. One is the A, C and D. So let's suppose the two triangle ADC, and the another triangle which you have to see that triangle ABC. So we have the two triangle ADC and ABC. So as you able to see that in this triangle ABC we have the line LN which is parallel to BC. That means in this triangle one line which is parallel to the one side of the triangle. That means you could use the concept of BPT. So as you know that you have to use the longest side also. That means you have to using the second step of the BPT, which I teach you already. This so using the BPT in this triangle you could write here the AM by AB, which is equivalent to AL by AC. Using the BPT, this side will be by this side and this side will by this side. Using the second concept or the second step of BPT, this is the other form which I already teach you when I am teaching the concept of BPT. So you could get this one by the triangle first. Now in the triangle second you will get that AN by AD, which you could write here the AN. Here we have the AN by AD which is equivalent to AL by AC. So here you could write the AL by AC. So this we you get through the second equation. Now when you will see over a closer observation that this one is also equal to this one and this one is also equal to this one, and in both of the equation RHS is equivalent. So if the RHS is equivalent, you could write here the AM is equal to AB and AN is equal to AD, and this is what we have to prove, that AM is equal to AB and AN is equal to AD. This is what we have to prove or required in this question. So I think you get to understood how we have to use the multiple concept of the BPT to solve a question, and thank you for today.